Okay, we've been looking at integrals, specifically at definite integrals. And if we're finding the integral of little f of x, then we're finding the antiderivative. So let's call capital F the antiderivative of f. So the definite integral, we would find the antiderivative at the top value minus the antiderivative at the bottom value. But what if those values are exactly the same? Well, you're going to get 0. What if there is a value c in between a and b? Well, one property says we could split it up. Remember, this is finding area under a curve, so we could find the area from a to c and add it to the area from c to b. If the area, let's look at this one, from A to B is K, then what if we switch those boundaries? So let's think about that closer. If we had the integral from A to B, that's f of B minus f of A. But if we switch the order, that's going to switch the order here. And what would happen to our value if you switch the order in subtraction? Well, it's going to make it a negative value. Well, wouldn't that also happen really any time that your upper value is smaller than your bottom value? It's going to switch the signs. So this is the same as doing the opposite of A to B. Same thing. If you switch the bounds, it's going to be the opposite sign. Now this one we kind of saw happen. If we have a constant being multiplied, it's just going to be that constant times the integral. Another property says if we have a function plus or minus another function, then we can split it up and find the integral of each. And then just add or subtract them together. What would happen if f of x is an even function? Well, even means it is symmetrical about the y-axis. So let's think about what happens if we had negative a there and positive a would be symmetrical here. Well, what's going to happen? Well, this area and this area are going to be exactly the same. So we could actually just double the area from 0 to A. Or we could double the area from negative A to 0. And what would be true if it's an odd function? Odd function is symmetrical about the origin. So negative A to A. Well, you're going to have the same amount of area below and above, so that's always going to be 0. Well, how does knowing these properties help you? Well, sometimes we're not given a picture, and we're not given a function that we can take the antiderivative of. We have to use these properties. So In these examples, we're given some values, and we have to answer other questions about it. Okay, so we've got the integral from 0 to 3 is 6, and then from 3 to 7 is negative 8. So what if I flip the boundaries? Well, that's just going to flip the sign of going from 0 to 3. So that was 6, and now it's going to be negative 6. What about if I wanted to go all the way from 0 to 7? Well, I could take the integral from 0 to 3 plus from 3 to 7. So the area from 0 to 3 is 6 plus a negative 8 gives me negative 2. What about if I went from 3 to 3? Well, remember, that's just the antiderivative at 3 minus the antiderivative at 3. It's just 0. Ooh, this one's good. We got a 3 being multiplied, and the 3 and the 7 are flipped. So it's going to be negative the interval from 3 to 7 times 3. Which is 24. Ooh, okay. Throwing in a 2 in there. Okay, 2 plus 3 times this. So that's really going to be the integral from 3 to 7 of the number 2 plus 3 times the integral from 3 to 7 of f of x. Well, the antiderivative of 2 is 2x. I need to evaluate that from 3 to 7. Now, the integral from 3 to 7 of f of x was given to us. That's negative 8. So I do need to evaluate this one. That's going to be 2 times 7 minus 2 times 3. That's 14 minus 6. Oh, I forgot this. That's a negative 24. So overall, I get a negative 16. The integral from negative 3 all the way to 3 if f of x is even. So even meant it was symmetrical about the y-axis. So from 0 to 3, it's going to be the same as from negative 3 to 0. So this is just twice as big as the integral from 0 to 3. So 2 times 6 is 12. What if f of x was an odd function? Well, remember, they're going to be opposite signs. From negative 3 to 0 would be a negative 6, and 0 to 3 would be a positive 6. It would be 0. What about given the graph? Will these properties help us here too? Well, let's see. First off, we're not given a function, so we can't do the shortcut of the antiderivative. What is the value from 0 to 3 of f of x? Now, the properties do help us in the fact that we can split this up. And I see that that's a rectangle. So I got a rectangle, a semicircle, or a quarter of a circle, and a triangle. So I would do 1/4 pi r squared, radius is 2, plus the rectangle is 1 by 2, plus 1/2 base times height, 1 by 1. So that's 4. Fourth of that would just be 1 pi, plus a 2 plus a half gives me pi plus 2.5. Now sometimes I find it helpful to fill in what I know in each of those areas as I find them. Okay. Now what if we went from 0 to 4? Well, this is below the x-axis, so this is going to be a negative 1/2. So 0 all the way to 4, we'd have what we'd already found, but then subtracting the 1/2 at the end. So I get pi plus 2. What about from negative 3 to 3? Well, if we think about it logically, negative 3 to 0 is exactly the same as 0 to 3 because it's symmetrical. So this is going to be 2 times the integral from 0 to 3, which is going to be 2 times pi plus 2.5, or 2 pi plus 5. If the antiderivative at 0 is 5, what is the value of the antiderivative of 3? Well, if I'm using both of these, I think it'd be helpful to use the integral from 0 to 3 of f of x. Because I know by FTC that means it's capital F of 3 minus capital F of 0. Do I happen to know the integral from 0 to 3? Yeah, we found it earlier. Do I know capital F of 3? Nope. Do I know this one? I do. So I'm able to solve for this value. We can do something very similar for this one, negative 2 and 2. So looking at the integral from negative 2 to 2 of f of x equals capital F of 2 minus capital F of negative 2. So I may have to look back at the graph for this one. Negative 2 to 2. So this area right here. Well, this is another pi, and this is a 2. So 2 pi's plus 4. Capital F of 2 is what we're looking for. This one's a negative 2. So that makes it and we'll subtract 2. Now the next problems you're going to practice are going to be some AP style questions.